So in this video we're going to take a look at your main objective in 8.1, which is being able to find the resultant of vectors. And we're going to be looking at two different methods in which you can find a resultant. Um, when the trick is with calculating a resultant is you got to remember that when a force acts upon an object, it goes in a certain direction. For example, if we were to have, say, an object here, just like so, and we want to have that object getting pulled in this direction with this kind of a magnitude, which is indicated by vector q, and then also take this object and pull it in this direction indicated by vector p, that object's not going to go in either one of those directions. When those forces combine, it's going to go in a different direction, most accurately going in this direction here and also getting pulled upon with that amount of force. As you can see here, notice that tire goes in all different kinds of directions. This is due to the fact that you have three different teams pulling on this tire in three different directions. Now, certain combinations here of the forces here cause that tire to go in different directions. You know, two forces can cause a tire to go in one direction, or three forces can cancel each other out where the tire stays put. So let's look at two different ways that you can calculate a resultant vector. One method is the parallelogram method. And in the parallelogram method, your first move is to take the two vectors, in this case vector p and vector q, and connect them tail to tail. As you can see with these two vectors, you have, for example, vector p, here would be the tail, and here would be the tip, as you can see by the arrow. So what we're going to do is take those two vectors and connect them tail to tail. And now you have one whole vector here of p, and then one whole vector here of q. And now what we're going to do with these two vectors is we can now duplicate them both in magnitude and direction, and put them to the tips of its other vector. And so now what we've created for ourselves is with the two tips pointing right here, is now we've created a situation where now we can say if the two vectors originated from here, that being where the two tails met, and they finish here where the two tips met, then we have our resultant vector right there. And that's our answer, vector p plus vector q. Now the second method we can use to create our resultant vectors is a method that the textbook calls triangle method, but you'll very rarely hear me say that. I'll refer to it pretty much every single time as the tip to tail method. Now, just as the name suggests, what you're going to be doing now with the vectors, instead of putting them tail to tail like we did over here with parallelogram method, we're going to take the two vectors and we're going to connect them tip to tail. Now, the good news about this, when it's vector addition like vector p plus vector q, it doesn't matter which one you put from tip to tail. So notice here we used vector p going here, and so now we're taking the tip of vector p and we're connecting it to the tail of vector q. So one thing to notice here is that the path of this vector would go in this direction here. We'd start here, we'd go in this direction here, and then we would finish going in this direction right here. And so now what tip to tail method now accomplishes here is if we had started here and went in this direction here and went direction here and we finished here, start and end, then that means that our resultant vector would start here and go in this direction and wind up right there. Kind of just making a shortcut. You'll hear me refer to that very frequently, is just we'll think of that resultant vector as being the shortcut. Let's just get a couple misconceptions out of the way with this in here, and when we take a look at the next example, I'll show you how students screw this up the most. Let's take a look at this example and let's create the resultant vector doing both strategies, and then you can see how they're very, very much related strategies here, and they're almost like doing the same thing. So if you have vector v and vector w and you're trying to add and find the sum of these two, your first step with the parallelogram method is to take these two separate vectors here and put them together tail to tail. Keeping in mind that's very, very important to make sure you keep the direction and the length intact as you create these vectors. Now that we have the two vectors tail to tail, now it's time to duplicate both vectors and transfer them over to create a parallelogram. Now that we have both of those made, note where your two tails began, notice where your two now completed tips finish, and now we can create our resultant vector here, which would start here at the tails and go right here to the tips. And so now we'll finish this off by writing in that this vector we just made here is vector v plus vector w. And that's the parallelogram method. Let's move on to tip to tail. Now tip to tail, we're going to kind of shortcut this process quite quickly here when we do these tip to tails. So the first move is just duplicate one of the vectors and put it on the page. Now that I have vector v placed on here, now with my second vector, vector w, take the tail of vector w and connect it to the tip of vector v. Boom. So now that we've done tip to tail here, now what we can see here is our path here of movement here starts from the beginning at v, travels all the way to the tip of v, and then picks up where, and w picks up where v left off and travels here. Well, the trick to writing your resultant vector now is to look at the path we had here and create that shortcut. We started here. Instead of going here and that way, now let's just do the result of that, which puts us right there. And so this is our solution here, vector v plus vector w. Notice that when I take these two red vectors here, they're exactly the same length and same direction. Okay? Now the number one way that students mess this up, I see this every year, is when they're using tip to tail method, they like to just complete a circuit almost. And so then they rationalize it this way. Well, if v goes from here to here and w goes from here to here, then our resultant would go back to where it started. Well, that's absolutely not the right way to go. Okay? Absolutely not. Remember what we're looking at here is if these were our two vectors here, we started here, we went up in this direction, we went down here, and we finished right here. So if that's where we ended, then our resultant vector has to go from the start to finish, just like that.